fractions. And when we observe, it's similar to ethanol in acid catalyst. Most of the free eject or pigment here comes from ethanol, usually outer layer of ethanol. And this is for papermaking outline for not bamboo. Not like the other reactions. Here in not bamboo, fractions B is more compared to fractions A. That's meant a lot of sides in this reject for not bamboo here. And mostly if we observe in the A fraction, most of the big knots here comes from interknot next to knot part and small portions of knot. And this is the reject analysis for interknot bamboo. Between A and B, there is a huge difference here, and the trend is with increasing time. A fractions getting increased and B fractions also. And when we observe here in A fractions, mostly the rejects coming from outer layer of internal bamboo. And this is the analysis, reject fraction analysis for dissolving acid for not bamboo. Here, even the A and B fractions is a huge difference here, and with increasing time, A fraction is getting decreased, while in B fractions and C fractions is going to increase. And when we observe the reject here, mostly the big knots here comes from interknot next to knot part and followed by small portions of knot bamboo. So in conclusion, Organosolv pulping method here, which employ glycol ether and catalyst, has been successfully to apply in interknot and knot bamboo. And in terms of fiber length, fines and thin content, papermaking with alkaline catalyst is better than acid catalyst. However, in terms of percentage of reject and short reaction time, you can say that papermaking with acid is more suitable for knot bamboo. And 6 characteristics here we got in knot part, such as lower pulp yield, lower screening yield, shorter fiber length, higher proportion of fines and lignin, and a tendency to generate more rejects during pulping. And last, as on the reject that generated in knot bamboo, most of the reject were transformed into near to knot part, followed by knot bamboo, and this is due to the use of average 22% knot bamboo. Thank you, and welcome to any questions.
질의응답을 진행을 하고 내도록 하겠습니다.
이 사람 처음 오는데 우리 내가 그래 뭐 수업도 안 먹고 했어.
So the presentations, I will give a few questions that we thought. First thing is the overall difference between the internode bamboo and the node bamboo in chemical composition.
Actually, we didn't mention the chemical composition here, and when we just observe from like lignin content that remain in the pulp and paper.
I mean chemical composition.
No, we didn't mention.
Okay. It looks like the node part has a higher lignin content compared to the internode part. So and then when you increase the cooking time and then have the yield decrease with over time as the time increases. So why is that? I mean, when you increase the reaction time, it means more lignin has been dissolved, and then you're supposed to have the higher yield, but that's not the case here. Why is that?
Basically, according to the theory, if we increasing the pulping time, more lignin and another material is removed during the process. Because we put energy, that means a lot of material from bamboo dissolved in our liquor. So that's why the yield is going to increase.
So that means the increased cooking time means to remove the more lignin and also some of the carbohydrate as well. That you say?
Yes.
Okay.
Thank you for the nice presentation. So, did you make a pulp or paper? Why do you use that? I use that tall paper making for the time. The many times
the research.
You made the product, right? It's not paper, right?
But this is just like a formula. So usually they do not understand that papermaking reactions, they use like the glycol atom with water ratio.
And all of your data show that higher standard deviation of node than that of the internal node. So how do you think that the way? So all of your data show that standard deviation of their node is higher than that of the internal node. You know that why the higher why the reason for the higher standard deviation of the node data.
Thank you. So basically for internal because this more continuous instructor and for node, when we can see here, the thickness is more variable here because we want to employ like paper as much as possible and it contains like the portions, small portion of node and another is internal. So that's why when we did the pulping also, the standard deviation here for node is higher compared to internal. See that more control.
Is there any standard to the whole division from the nodal portion from the internodal portion? Is there any standard? 저 만들자는 기준이 it depends on the man. Is there any standard for division of the nodal portion from the internodal portion?
How you separate the node
Yeah.
and internal? Do you have any like you want the baseline? When you selected, you say the 22% node part. How you measure that one?
This is based on weight. So
I'm not know. How you define? How you tell the node and internal? You know the right hand side picture show that the different internal area different. Each sample, that's not the same.
Yeah.
That means there must be variation because you include internal part in as well as node part. So that when you said node part, there's much variation including internal part as well. So actually, when we start your experiment, you have to define what is node part, what is the internal part. When you select a sample, your expression is wrong. Whenever you do some kind of comparison experiment, I always say choose the similar, and then when you say okay, inner part and the outer part, you have maybe 0.5 centimeters between in the middle. You have to prepare that one, right? So that's why your standard deviation is much higher than one. So how did you measure the knot part? So you say 22% knot portions. How did you measure that one?
So I measure using like I measure volume of the node here and comparing to the part and I got the weight for node wall and I got the weight for the average of.
So what is the centimeters? I tell you, you have to pick up the centimeters in the middle of the knot part. The up and down, how much there was? So what's your conclusion? When you start in the hypothesis, could you show me your hypothesis? So what is your hypothesis? You try to using not bound, right? Go to your final conclusions. So what? You suggest that number 2. So acid papermaking, acid pulping is best way. However, your conclusion number 4. This is due to use the average 22% not bound. So basically,
if you're using node part, your most of your node is rejected, right? So your hypothesis and your result is different. You cannot use node part because your all the node part go to the reject. It's not going to be valorized of the material.
It's again depend on reaction type with papermaking with acid because I have like 7 until 5% reject, so we can still employ more this number.
So what does it mean? So can you logically draw conclusions as the pulping is better than alkali pulping or dissolving pulping?
Papermaking with acid catalyst is better compared to the other type.
Last time I told you, if you're using that pulp, if I want to bleach the pulping, the pulp, the acid pulping is more higher lignin content compared to alkali. So we have to spend more bleaching chemical, right, to get bleached pulp.
But to assess this thing also we need to think about the preparations, like we use just small amount of acid catalyst, just 3% compared to the alkali that we use 20%. So basically, if we think about costing, we have to think like from preparations until like the black liquor as well, like in alkali, in acid, because just small amount of concentrations is easily to recover or even to reuse the solvent as well.
So basically you're using 20% node, and if you say your hypothesis is like that, okay, we have to use node part because it's going to be what? Raised, right? So 22% is not enough. It's not representative of the node part. If you're using more than 50 or 60 or 90, in that case, okay, maybe you can draw conclusions. But 80% is very sound internal boundary. How you solve that one is completely your the hypothesis and your conclusion, in my opinion.
So for the following further research, we need to employ more than 90% more part from the part, so we can get exactly the portions of reject there and define exactly what is the coping and something.
Okay.
목소리 우리말로 아마 절이라 해야 되는 저분이 그 버리는 게 꽤 많은 것 같아요.
버리지 잘라요. 많이는 버리지. 그래서 나머지 대나무
그 구성 가지고 일단 선로를 시키는 게좀
그게 저 친구한테 얘기를 하는데 원래는 이게 이것만 하다가 안 되면 일단 시작은 이거부터 실험 같은 거 하고 포션을 굉장히 작은 거 포함해서 시켰는데 원래는 90% 이상 절을 하려고 했는데 아직까지 열심히 하고 있습니다.
전체 대나무에서 모든 파트 차지하는 게 중요하고요.
How much percent the another part in the hoop? I told you you have to analysis that one.
In the world
In the whole bank, how many percent of the total amount?
I didn't measure yet.
그게 뭐 예를 들면 그게 20% 정도라고 하면 저 과정인데 전체 호흡 앰플을 사용할 수 있다는 의미가 있을 것 같아요. 저는 그렇게 생각을 했었는데
아니.
그런 게 아니고
그거는 원래 없애는 게 맞고 이게 그린이 많은지 안 많은지 하지도 않았고 그러고 중요한 거는 이게 조직이 침하라는 건 맞는데 이 부분을 그냥 간단하게 내가 대나무로 가지고 펄프를 만들려고 하면 그냥 집에서 해야 되는데 이걸 다시 잘라야 돼요. 그러면 이 자르는 공정이 들어가기 때문에 자, 그러면 얼마큼 잘라야 되냐? 그러면 이걸 얼마큼을 하는 게 맞느냐? 라는 의미에서 아니면 아예 없애야 되는 건지 아니면 그냥 이거 인보는 들어가도 별 문제 없을 것인지. 근데 문제는 저기는 다 리젝트가
다 리젝트가 되니까
다 리젝트. 그러니까 사운드한 인터널로 리젝트가 되거든. 그래가지고 이거를 원래는 그 나도 90%짜리를 해보면 이거를 그러면 뭐 사운드하고 이걸 우리가 어떻게 쓰냐 하면 페이퍼 메이킹 펄프로 만들 것이니까 아니면 진짜 완전 강하게 반응을 해서 디소빙 아예 그 용액화물로 만들까라는 거였는데 지금 결과는 용액화물이 별로 안 좋고 S가 나오는데 이상하거든요.
아니, 이번 제주도에서 그 뱀부 그 자료를 봤는데 중국의 그 학교를 이런 중국잖아요. 그 학생이 들었더니 보니까 저걸 무리적으로 해서 뱀부를 가지고 굉장히 강도가 좋은 이런 항산제품이나 원통이나 그런 건축 재료를 잘만들었다고 합니다. 그래서 내가 몇 년 전에 중국에 갔을 때 보니까 대나무 순 가지고 옷을 만들더라고요.
그렇습니다. 그게 디소빙 펄프입니다.
아,
그래서 그걸 녹여서 그게 뭐 강화시키면 됩니다. 그걸 하려고 그 원재료로 만들려고 했는데
저희 성분이 다른가 봐요. 제가 넣어도요.
조직이 다 조직이
약간 그런 특징을 안 가지고 있습니다.
치밀을
조직이 침이라.
특히 그냥 표피가 잘라보면 안에는 괜찮은데 이 표피가 좀 굉장히 쏠리다.
설왕설래가 많지만 오늘 랩미팅 하는 줄 알았습니다. 고생하신 모든 분께 감사드리고요.